All right, this section we are going to look at SOHCAHTOA. So right triangle trig, we're going to review over this, and we'll also be doing a couple of word problems, pretty basic word problems with SOHCAHTOA. Now the assignment that goes with this, I do want you to do, you'll see it says required when you look it up, but that is posted for you. Okay, so SOHCAHTOA, remember sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Then you have your other three trig functions, your reciprocal trig functions here that match up. So sine and cosecant are reciprocals of each other, cosine and secant, and tangent and cotangent. Okay, number 9, find the third side of the triangle and find all 6 trig functions. So it's a right triangle. You can do Pythagorean theorem. So 3 squared plus 4 squared is c squared. Solve that. C will be 5. Now, finding all 6 trig functions, I generally do your sine, cosine, and tangent first. And then all you have to do is do the reciprocals of these 3, and that will give you your others. So sine, find where theta is. Sine is opposite over hypotenuse. So the opposite leg is 3, hypotenuse is 5. Cosine's adjacent over hypotenuse, and then tangent is opposite over adjacent, so that's going to be 3/4. Cosecant is just the reciprocal of sine, so that's going to be 5/3. Secant is the reciprocal of cosine, so that's going to be 5/4. And cotangent, reciprocal of tangent. Okay, B, same thing. We're doing the same thing here. You can use your Pythagorean theorem again to find your missing side. This time the missing side is a leg. So it's going to be 3 squared plus b squared is 3√2 squared. When you square this 3√2, the 3 gets squared, turns into a 9. √2 gets squared, which is 2. So this is 9 plus b squared equals 18. And then you can move your 9 over. And then solve for b. B will be 3. Okay, now if you recognize this, this is actually a 45, 45, 90 right triangle. So you have x, this other leg is x, and then your hypotenuse is x√2. So whatever the length of the leg is times √2, and that's your hypotenuse. So if you recognize that as a 45, 45, 90, you could use that pattern to find your missing leg. Okay, so sine is going to be opposite over hypotenuse. Oh, I forgot to tell you which angle. Let's use this angle is our theta. Okay, so opposite of theta is 3 over hypotenuse, 3√2. That's going to simplify to 1 over √2. Now you'll notice we have a radical in the denominator, so you will need to rationalize. And this becomes √2 over 2. Okay, cosine. Actually, the same thing happens with the cosine because you have adjacent over hypotenuse. Again, simplify, rationalize, and it will also be √2 over 2. Tangent is opposite over adjacent, which is 1. Okay, so your reciprocal functions, cosecant is the reciprocal of sine. Now I would use this one to be my reciprocal, because if I flip that one, or even my original statement, I could flip it and then reduce the 3's. You'll have √2 over 1, or just square root of 2. Secant will do the same thing. It'll be square root of 2, and then cotangent, reciprocal of tangent, that will be 1 again. So, okay, 10 and 11 are example 10 is similar to the previous example, but instead of giving you a triangle to work off of, you're just given a statement. So this is sine is 2/7. Well, remember sine is opposite over hypotenuse. Okay, so if I think about a triangle, I'm just going to sketch out a generic triangle. My hypotenuse is 7. My opposite side is 2. I'm going to use this as my 2. And since that's opposite the angle measure, my theta will be here in this corner. Okay, so you're going to be using Pythagorean theorem again to solve for that missing side. So once you do that, you're going to have 2 squared plus b squared equals 7 squared. So b squared actually ends up being 45. And then when you square root that, 3 root 5 is that simplified version. So 3 root 5, do a factor tree, and you'll find that missing. You'll simplify that. Okay, so same thing again. You're finding the trig functions. Well, we already have sine, so we don't need that one. So cosine, tangent. Cosine, adjacent over hypotenuse, so 3 root 5 over 7. Tangent is opposite over adjacent, so 2 over 3 root 5. So this time, we're going to need to rationalize again. You could just do the root 5. So equals 2 root 5 over 3 times 5 is 15. Okay, then I can do the reciprocals. Well, since sine was 2/7, that means that cosecant would be 7/2. Okay, I have cosine, so the reciprocal of cosine is secant, and reciprocal of tangent is cotangent. So reciprocal of secant, reciprocal of cosine would flip this, would flip that fraction, and we're going to end up having to rationalize again. So this is going to be a root 5 over root 5. So you get 7 root 5 over 15. Okay, cotangent, I would go back to my original tangent, because when I do the reciprocal of that, I'll get 3 root 5 over 2. And then I don't have to mess with flipping that final answer and then having to do some rationalizing. Okay, B. All right, I want to get at least started on this one. B, secant is 4. Okay, well, secant is the reciprocal of cosine. So if secant is 4, cosine is 1/4. So you might want to think of it in that respect. So cosine is adjacent over hypotenuse. So I'm going to let the 4, well, the 4 is the hypotenuse. The adjacent side, I'm going to call this 1. So if that's adjacent to theta, that means theta is here in this corner. Okay, then you can do your Pythagorean theorem, and the third side is ends up being square root of 15, and then you can go through and do your 6 trig functions. Okay, next, calculator. So let me get my graphing calculator. Give me just a second. Okay. All right, so on my calculator, cosine of 18, especially if you're using the app, if you look up at my top, it says that it's in radian mode right here. So every time you close out your calculator, it defaults back to these settings. So you will want to make sure that either you go into your mode and change it 2 degrees, which is the third one down, enter, or you get the degree symbol. Okay, so cosine 18, I'm in degree mode, so I'm good here. So this will be 0.951. Okay, tangent, you can do tangent of negative 218. Use your negative sign, not your subtraction sign. So this is a negative 0.781. Okay, secant. So secant and cotangent. I don't have those buttons. So what you can do here, secant is the reciprocal of cosine. So I probably would do it this way. To me, this is the simplest way to think about it. So it's 1 divided by cosine of 20. And 1.064. And then cotangent, I'm going to do similarly 1 over the tangent of 200. There is another way to do this. Well, let's do the 1 divided by tangent 200 first. So 1 divided by tangent of 200 is 2.747. Okay, the other way I could do this is I could go ahead and do tangent of 200 degrees, and then I'm going to get that value. Then I'm going to do the inverse. So over here to the right, right above your x squared button, is your exponent to the negative 1. So remember, that does the reciprocal. Negative exponent means you're going to do the reciprocal, and that will give me 2.747. Okay. Now, using that reciprocal button, that x to the negative first, is different than using the inverse tangent. Okay, so keep that in mind. That's two separate operations and they mean different things. So that's really why I think it's easier just to do my original option of doing 1 divided by tangent of 200. I think that's easier than trying to keep track of which button I can use or can't use in this situation. Okay, so we're going to stop here. I've got 3 word problems that I want to show you, but I will put those in as an additional recording.